Right, the previous video showed how a Toy A program can output data to the teletype. And this one shows how to input data using the keypad. Now these two are the only I/O functions available on Toy A, but they're just enough for basic computation, which is what the Toy architecture was designed for. It was a teaching aid for students at Princeton University in the USA. Now PlasMa can run other emulations, and these have many more I/O functions, but I'll cover those later. And last time we saw that the final memory location, hex FF, is sacrificed to provide the two I/O functions. And this time we're going to read from that location. We can use any instruction which reads from memory. I'll use the 8 instruction, load memory contents to a register. And I'll use register 3, so here's the instruction. 8 for the opcode, 3 for the destination register, and FF for the special memory address. I'll confirm PC is 0, and the target load light is set for the instruction register. So I can now press load and ink. I'll add another instruction to print the value on the teletype. And we covered this last time, so I'll use the same instruction, store register to memory. So we want 9 for the opcode, 3 for the source register, and FF for the special memory address. Press load and ink. And finally I'll add another instruction to jump back to the beginning so we can repeat the test. We saw this last time. C for a jump, 0 for the condition register, which is always 0, and 0, 0 for the address. Load. Okay, the program's loaded. It should read a value from the keypad, display it on the teletype, and repeat. I'll just step through the instructions to check it looks okay. There's no point running it if I've misentered it, and I've done that before. So we can use the Ink and Deck PC button. I can set PC to 0 and confirm the instruction, and that address is an 83FF. Increment PC, address 1, the instruction is 93FF. Increment PC again, address 2, and the instruction is a C000. That looks okay, so we can now reset PC and press run. The keypad light up here has come on to show the program has stopped and is ready to accept input from the keypad. And the value I enter will be stored in register 3. Now before we go further, I'll just explain how it works, as I've modified the behaviour slightly from the original Princeton design. This is one example of how instructive it is to start from scratch, as so many features, even trivial ones, are taken for granted nowadays. I may be wrong, as I was never a student at Princeton, but from the documentation, and I'll leave links in the description below, it looks like the program either continued automatically after 4 hex digits were received, or you pressed a special continue switch. I also presume they had a software simulator which the students could use, so this would have had the benefit of displaying the value on the computer screen while you typed it in using the QWERTY keyboard. And maybe you could use the backspace key for correcting mistakes, and maybe the enter key for accepting the final value. Now with a raw machine like PlasMa, there's no obvious place to display the value. The screen is reserved as an output device for the program. In Toy A it's a teletype, so it wouldn't be right to scribble all over it with other values. There's also no luxury of a backspace key or an enter key on this keypad. The 16 buttons are nominated to be the 16 hex digits 0 to 9 and A to F. The bottom line is, if it only accepted the first 4 button presses, you have no chance to correct a mistake. So PlasMa's strategy is to use the target register itself to display the value as you're entering it. And it does this 1 hex digit at a time by shifting them into the register from the least significant end. I'll press some buttons. 1, 2, 3, 4, and you can see the values here 1, 2, 3, 4. Now if you press more than 4 buttons, the most significant nibble will drop off. I'll put 5, and now the register shows 2, 3, 4, 5. And you can press as many buttons as you like, so if you make a mistake, just keep pressing the buttons until the register contains the right value. And when you're happy, press the run switch. The program continues. Now, having control over when the program continues also means you can do this with any of the execute switches. We can run at full speed, run at medium or slow speeds, or even single step, which is all useful if you want to diagnose a problem in that area. Okay, so we've continued from the input instruction, and we should now see the value displayed on the teletype. And the keypad light is lit again to show the program has looped round and is now waiting for the next number. And the labels on this off-the-shelf keypad were almost okay for use as a hex entry device. The star and hash represent E and F. I'll zoom into the screen and do a few more. Okay, 4, 5, 6, 7, run. 0, 0, 8, 9, run. E, F, A, B, run. Okay, that's all I wanted to cover in this video. There's plenty more to demonstrate, but this is probably extremely boring if you don't have a machine to follow along. However, there is a simulator on the Philisound website. It's called PlasMa Sim, and it replicates almost everything in this real machine as it shares the same code. So this is a topic planned for next time. I'll show how to set it up, and I'll run through some of the same programs we've done up to now so you can see the similarities, and then we can move on. So see you then.